In the first part, I have discussed about Clairaut's form and how to solve the equations. But there are some equations which are not in Clairaut's form and can be reduced to this form. And there is no hard and fast rule. However, a suitable practice can give the intuitive idea to how to substitute these things. But there is some important substitution. I will discuss about 3 substitution. And first form is y square equals py upon x times x square plus some function of py upon x. Let's understand this by an example. Example, x square times y minus px equals yp square. Okay, let's manipulate this equation 1 into the form. So first divide the whole equation by x square. We'll get y minus px equals y p square upon x square, or y equals px plus yp square upon x square. Now we have to put in the form 1, so multiply the whole equation by y, you'll get y square py x, but we need py upon x, so we have to multiply again here, so x square plus y square p square x square. So this can be written as yp upon x whole square. So this is in the first form, and here the important substitution is y square equals p and x square equals u. Now let's call this equation 2. Substitute y square equals v and x square equals u. So 2y dy equals dv, 2x dx equals du. So therefore dv upon dx is y upon x dy dx. Let dv du, not x, dv du equals capital P, y upon x and here small p. If we substitute these values, y square equals v, x square equals u, and y upon x small p equals capital P, we'll get v, so 2 becomes v equals capital P u plus p square. And see, this is the equation in Clairaut's form. But the unknown function is v and the non-function or independent variable is u. So therefore general solution is v equals, just replace the derivative by arbitrary constant, so cu plus c square. C is arbitrary constant, but our original equation is in y and x, so substitute back the values of v and u. So b is y square, so therefore y square equals c x square plus c square. This is the general solution. So sometimes just substituting y square equals b will transform the given equation into Clairaut's form. And let's see by an example. Example is y equals 2px plus y square p cube. Okay, so if the substitution is y square equals b, then 2y dy dx, just differentiate with respect to x, will get dv dx. So therefore this is nothing but 2yp equals dv dx, or we can say this equals capital P. So we have to multiply by y this equation 1, say to multiply whole equation by y, we will get y square equals 2py times x plus y cube p cube, or b equals 2p y is nothing but our capital P x plus yp is capital P upon 2 cube. So this is nothing but the equation in Clairaut's form. Equation in Clairaut's form. The unknown function is v and the independent variable is x. So therefore general solution is p equals cx plus c cube by 8, where c is arbitrary constant, but we have to substitute back the v values, or y square equals cx plus c cube by 8 is the general solution of this equation. Form 3, another important form is e to the power by times a bp equals some function of p into e to the power by minus ax. And here we substitute e to the power by equals b and e to the power ax equals u, and this form equation of this form will reduce to the Clairaut's form. Let's understand this by an example. To the power 3x times p minus 1 plus p cube e to the power 2y, or we can write this whole equation as e to the power 3x 1 minus p equals p cube e to the power 2y, or multiply this whole equation. Okay, first divide this whole equation by 1 minus e to the power 3x, so we will get p cube e to the power 2y upon e to the power 3x, and then multiply this equation by e to the power y here, e to the power y. So what we will get, e to the power y times 1 minus p equals p into e to the power y minus x whole cube, because here e to the power 2y plus y in the power, we will get 3y minus 3x, So the whole thing looks like this. And see, this is the form 3. Here the b is 1 and again a is 1. So therefore we have to substitute, let's say this is a star. Substitute e to the power y is v, and e to the power x is u. So what we will get, e to the power y dy equals dv, and e to the power x dx equals du. So therefore dv du is nothing but e to the power y upon e to the power x dy dx, or this is nothing but, let's say, capital P here, and e to the power y upon e to the power x, this is a small p. Or we can say e to the power y is v upon u small p, or small p value is capital P u upon v. Now change this, substitute the values in star. So star becomes e to the power y is v, 1 minus small p is nothing but capital P u upon v, and on the right hand side this is p y e to the power y minus x, that is capital P whole cube, or we can say v minus pu equals capital P cube, or v equals capital pu plus capital P cube. And see, this is nothing but Clairaut's form. The unknown function is v and the independent variable is u. So therefore general solution is v equals c u plus c cube. C is the arbitrary constant, but we have to substitute back the values of v and u. In this case, v is e to the power y and u is e to the power x plus c cube, which is the solution of the equation 1. Again, I'm saying that by suitable substitution, some equations can be reduced to Clairaut's form, but there is no hard and fast rule.